Okay, we'll get going. So, yeah, for those that are still coming in, welcome this afternoon to the ASBP webinar on reusing concrete in construction. Our Reuse Now campaign is sponsored by Cleveland Steel and Tubes, Optima and Reusefully, and we very much appreciate their support in sponsoring our work. If you want to find out more about sponsorship, we've got gold, silver and bronze sponsorship of our campaign. Lots of different benefits around getting involved. A few points there, but I won't go through them. But please get in touch if it's something you might be interested in getting involved with. So the agenda this afternoon is Elaine Toogood's going to give an overview of the concrete reuse in the UK. Tom from JFN's going to speak about cracks and give some case studies around what they're doing there. Then Serkan from the Technical University of Denmark is going to talk about some policy work that's happening in Denmark. Excuse me. And then lastly, Laura from Heyne Tillett Steel is going to talk about towards a concrete circular economy and bring things to a bit of a conclusion on the presentations. And then we'll do about 20 minutes on the panel Q&A. So just a little bit of an overview on the ASBP, the Alliance for Sustainable Building Products, for any that don't know too much about who we are and what we do. We're a not-for-profit, mission-led sustainability organisation. As you can see there, our mission is to accelerate the transformation to a healthy, low-carbon built environment by championing the use of demonstrably sustainable building products. When we first began, we're very much more focused on manufacturers and product areas specifically, but we're very much of a broader church now, engaging also with architects, engineers, contractors, developers, and consultants. And you can see there those 6 different pillars that are the different aspects of work that we get involved with. So the resource efficiency pillar, and very much linked in with that whole life carbon, but also health and well-being, looking at things like damp and mold, indoor air pollution, and then ethics and transparency and social value, as well as the technical performance aspect, which very much fits in with some of the different working groups that we do, like the natural fibre insulation group and our paints and finishes group. I would urge you to have a look at the website. We've got a lot of information there that's available, free to download. And there's also information there about membership, if that's something that you're interested in. And we also not only have our events, but also our members and partners events. So lots of interesting information on the website. Just a little bit more information about our Reuse Now campaign, which I lead on. We work both with our members and the wider construction industry to accelerate the transition to a more resource efficient circular economy. And we do this through events such as this webinar and our Reuse Summit next week, but also do some deep dive research work. So we've done the reuse of glass partitioning systems, and we're looking at the reuse of doors at the moment. And also, again, lots of other information on the website around different signposting to different reports and other case studies, in addition to the work that we do ourselves. As I say, we've got the Reuse Summit next Thursday. If you're interested, we still have a few tickets available. Again, if you hop onto the website and have a look there, Larry, if I'm sure he's probably put that in all there already. I can't see it. There'll be a link there to register for those last few tickets if you're interested. We also have some exhibition stands, just 2 or 3 exhibition stands available as well. Few housekeeping comments. So if you can add questions to the Q&A, not into the chat, you can also upvote and comment on other people's questions, which, if we have quite a few, is useful for the panel session at the end. Please don't use the raise hand option. We can unmute audio if you want to ask questions yourself, or if we've got a lot, we might just quickly ask the questions on your behalf. Some of the questions the panel might answer directly into the Q&A. Please, if you have any technical problems, drop a note to Larry in the chat. And we are recording the webinar, so if you'd rather your audio not be put live, but you do want to ask a question, then just tick send anonymous. So yes, I will now hand over to Elaine and get moving with our presenters.
Thank you very much. Thank you. I'm just going to share my screen. Hopefully you can see that. You let me know when you can see the screen.
Yep, that's good. Thanks, Elaine.
Fantastic. Thank you very much. And thanks very much for inviting me along today. My name's Elaine Toogood. I'm Senior Director at the Concrete Centre and MPA Concrete. And I'm going to just give an overview of the context really for the reuse of concrete in the UK at the moment. And let's go through. Is that working? Yeah. And the way I'm going to do it is I'm going to be using the hierarchy that's set out in the iStructures hierarchy for the use of concrete. Hopefully you're familiar with this. So, and you can see that there's six tiers there, 5 tiers there. Top ones are all to do with reuse. So I'm going to use this as the basis for me to explaining how concrete is used and reused in the UK. Now, first thing, there's loads of examples. I mean, it's one of the really key benefits of concrete, isn't it? It's there's loads of concrete structures enabling that durability, enabling it to be used and reused for many decades. I normally put up a picture of the Pantheon at this point, but of course I'm looking at the UK context of a Scottish viaduct there. But concrete, by its very nature, is durable and low maintenance, but I think in the context of reuse is a really important thing that needs to be factored in, because that helps prolong its serviceable life, especially in a culture where we don't maintain very effectively. So that being able to be resilient underneath an unmaintained flat roof, for example, really helps, or it's a potential for us to be reused for longer. It's not it's a considerable thing that needs to be thought about. Many of those examples are whole buildings. So if we're talking about components, actually, in many regards, you can talk about the entire building as being a component, and I call that the milk bottle strategy. So whether it's change of use, as these three examples, from offices into residential and hotels, or just extending that life. And in fact, both of these examples, the concrete didn't need much more than a clean. Actually, I mean, there was some other work done internally, and there's some floors added in the standard, but it shows you the potential of it, and there's some very more examples starting to come through. There are even more, I would say, examples of projects where the concrete frame is being refurbished and reused, and that's often previously, I'd say, often getting labelled as being a retrofit project rather than acknowledging that this is actually really good reuse practice. Many of those is where the soft bits are being exposed, so it's tapping into that existing thermal mass potential of that structure as part of a low energy strategy. So there are many examples of those around the country. And as I said, I think that does seem like the numbers are growing. So why is that? Well, I think there is increased recognition, the growing heritage value attached to 20th century architecture. And we know that we built a lot in concrete during that time. But of course, that combined with expanding number of planning policies that are prioritising retention over demolition. But I think carbon is a big driver for this. And then so project aspirations. If there's a focus on upfront embodied carbon, which seems to be one of the main focuses, that definitely one of the easiest way of being able to achieve that is to reuse the frame and the substructure. So I think those are all key drivers for why there's more reuse of in situ. Why is there so much concrete being specified, specifically being reused? Well, as I said, there's a lot of it about, but actually I think it's also pretty easy to do by comparison of chopping up and moving it elsewhere. There is, as I said, the durability is a potential, and if everything else is able to be removed and extended, is robust enough to enable it to be able to, for things to be stripped back from the building. And in fact, that aesthetic of like, as you can see on the example here, the Halford channels for the cladding is just left in there, and it doesn't matter. It can still work. It can still meet minimum fire requirements, and in a way that aesthetic is being celebrated. I think probably more fundamental is actually that the methodologies and the design standards for establishing suitability of existing concrete and reusing it are well established, and it's part of the role of structural engineering. Now, there's still more expertise and understanding needed there, and training. A lot of that is evolving as more of this is going on. There's more guidance being made available. The iStructure have done a lot of work in this field, but also it's worth understanding that we've a very well established supply chain for the refurbishment and repair of concrete. people have been doing this for a very long time. So that already exists and is thriving, as you might imagine. So lots of opportunities, but why, and maybe supporting why more of this is there, but what are the challenges? Well, there's a few on the screen here. They're not specific to concrete, but I think a lot of it is about spatial restrictions and flexible layouts, particularly with mid-century, there's the low floor to ceiling heights. Capability of energy efficiency. So this isn't just thinking about an upfront carbon, you know, what capability is there for that retrofit? It's not always straightforward, especially if the facades are being retained. Lack of data. It's a key one about that makes it really quite challenging in terms of the, you know, understanding what that original design is for subsequent alteration, maybe limited loading capacity. Timely access to site investigation. So much of this is about site investigation, knowing what you've got, and that isn't always conducive to sort of predicted costs and planning of the project. And I'm going to put VAT in there as well. We all know that that's a limitation potentially. So what about next tier down? So how many of these buildings are being moved completely and being rebuilt? Not many, I would say, especially in the UK. I think that really does rely on the design being fully set up to be disassembled and reassembled. And we're only starting to see a few of these starting to come through within the UK and haven't had their life hasn't been used up yet, so they're still in place and haven't been disassembled. I think arguably they're most appropriate and the main place where these are looking at things like car parks or agricultural industrial units, so things that have a temporary life on them. There is the potential for this to be increased, but I wonder if this is really the right thing for structural concrete. I would argue that actually keeping the structure in place and just design for disassembly for everything else is maybe the more effective route. Something to discuss later, maybe. So the reuse of precast, it isn't that uncommon, I would say, in the UK, but they tend to be at small scale. So you're talking about small paving slabs and small unattached elements. They tend to be moved about and reused quite a lot. There's not that many examples where buildings have been, again, because there aren't that many that have been designed for disassembly in the first place yet, but those are starting to come through. But have they moved? The whole of the upper tiers of the Olympic Stadium were all designed to be disassembled and removed and used elsewhere, but they're still in place many years later. But there is potential. Spacehouse is a nice example where that precast cladding was removed and then relocated further up the building as part of the building extension. So I would say, and we're going to hear later on about some of the Scandinavian standards. We are not as well progressed in the UK with regards to this. We don't have any standards for the reuse of precast units in the UK yet. And I think it's fair to say that there's a lot of, we're looking abroad to see how things are going. Next tier down, monolithic elemental reuse. Basically, this is salvaging large bits of concrete and using them as components within the buildings. Now, again, there are not many examples of this in the UK, but it is an area of real interest. There's a lot of work going on. We're going to hear a little bit about that from Laura later on as well. There's a number of projects starting to explore this in London. There's a lot of work going on the desktops at the moment. And I think there's a lot of learning happening from elsewhere. And Euston Tower we're featuring an event next week where we're looking at the work that's been happening there with regards to exploring the taking out of a section for reuse. I thought it was worth just putting in just a few of those exciting European-based projects that are inspiring a lot of that work and research that's starting to happen within the UK. But these ones are all related to structure. And I wanted to put in here, maybe mainly for the discussion later on, is that the potential for different opportunities that concrete offers for reuse. So these are all elements. One on the left is existing concrete panels that have been salvaged and cut up from a building, but then using concrete as the backing. They've been used as cladding on a project in Denmark. The one on the right is a more experimental structure, but again, using slabs of concrete cast into concrete. So reusing it when this is a structural exploration prototype that's being developed by EPFL. So a different way of using it. So many examples, again, as people dipping their toe into the beginnings of how this can be used. But I wanted to end on, and I know we're talking about reuse here, but I've got to get in there, reuse of aggregates. Okay, I know we're talking, because they are a commodity in themselves, although they're much smaller, and typically this is within the context of recycling. But as an element, as a product, they are used potentially ad infinitum within the built environment. And I just wanted to draw attention to some research and innovation that's starting to happening within this field. And so that's taking that components of the material by deep cleaning that aggregate. It's actually taking it much closer back to its original performance, and therefore potentially, as well as providing some recycled concrete fines or paste that have some real potential from carbon savings point of view, that aggregate then has greater potential to be reused potentially back into concrete itself as well. So I just worked my way all the way down through that pyramid and a very, very fast overview. But I think really what I wanted to say is, in summary, there's quite a lot of reuse of existing concrete structures in place. I think we would anticipate there's much more of that coming through, but the uptake of that and some of the more innovative and other uses is going to depend on very many factors. So not just policy and supporting and requiring reuse, but standards to facilitate them when they become products. When does that kick in? I think passing the data forward, so material passports, digital twins, e-tagging, that's all going to facilitate that. But I think what's also important for us to recognise that a lot of this is about the feasibility of it. There needs to be a market for it. But what is the context? What's the context of the cost and carbon of transportation, moving heavy elements about? You know, and how does that shift? At the moment, that isn't really conducive to moving these things around. It's not worth it. But at what point, when those things change, might it be? And of course, linking supply and demand is an important part of that. So that's really my talk. I just want to say that in the concrete industry, we're doing a lot in this work. One of our commitments is enabling greater circularity. So what can we do as an industry to support greater reuse? Well, one of the ways we do it at the moment is by sharing best practice. So this is hopefully part of that. We're doing a lot of that. We have a conference called Circular Economy. Click onto that. We've got some events coming up all next week online. And yeah, always interested to hear and learn about good practice so that we can pass that on and share it so that people can be using concrete to the best of its ability. So that's me. Thank you very much.
Thank you very much, Elaine. That was really interesting. I think particularly kind of that shearing layers concept of the frame often being more than capable of being around for longer than other components in the building, and potentially end of first life at 40, 50, 60 years, that the concrete frame can go on for so much longer, and Absolutely. How we can maximize that by ideally reusing in situ. Yeah, that's really interesting. Thank you. I'm just going to hand over now to Tom, please.
Good afternoon, everyone. Sorry, my camera was in a bit of a delay there. I'll just share my screen. Perfect. I hope everyone can see that. Yeah, great. So a little bit of a background. I'm Tom Seath from John F. Hunt. I'm Sustainability Manager. John F. Hunt is a construction company predominantly based in central London. The company itself started mainly as a demolition company, and now is sort of moving into the construction elements as well, with RC frames and other aspects as well, basement digs and the like. A huge part of what we try and do is through innovation within the materials that we use. Obviously, we sort of manage materials going out of projects and then hopefully back into the same project as well. And without getting too niche about it, but we're trying to close the circle in that regard, and we're trying to do that especially in concrete, and that's what I'm going to be talking about today. So like I mentioned, a lot of our jobs previously factored around demolition, and what are the business as usual techniques when it comes to comes to demolition, especially around concrete elements. So traditional demolition techniques sort of utilize hydraulic breakers, jackhammers to fragment concrete structures. Basically, this is done because it's easy to remove the concrete elements from the rebar elements. And obviously there's market for the rebar elements and obviously market into recycled aggregates as well. So we try and separate that. Reinforced elements are segregated for recycling and disposal as well. So like I just mentioned, onto RCA, and they're usually transported off-site. Some are crushed on-site as well. RCA is currently repurposed in sub-base layers, sort of non-structural concrete or fill material, whether that be pile mats and other applications, and reduces the landfill waste and demand for virgin aggregates from that. But obviously, recycling as a whole isn't specific to reuse, and the reuse of concrete elements, like Elaine just said, I'm going to be talking more about that monolithic reuse in concrete. And one way we can do that is PREX. Now, PREX is stands for piecemeal reclamation of existing concrete slabs. Essentially, I'll go into more detail, but essentially what it is cutting out concrete slabs to be reused and repurposed into slab elements in the future. So as you can see from the picture on the right hand side there, this is just a markup of a potential project where we've marked up concrete slabs that can be taken out, repurposed without impacting demolition operations moving forward. So cutting and removal of elements of concrete slabs for future reuse can be reused in future slab construction or in other concrete elements in the new development. So we're in discussions whether it's in a slab element or could be decorative, like Elaine said a minute ago as well. Not only does this reduce the waste, but it also reduces the need for new concrete in future developments, reducing that embodied carbon figure moving forward. So what we've done a lot of work at John F. Hunt to try and work out a process because it's not particularly large scale at the moment and not many contractors are doing it. So what would the strategy look like, and what might this actually happen at the sharp end of the stick as we are? So what we tend to do, or what we're thinking about doing, is marking out slab locations and give them an ID. Elaine mentioned a minute ago material passporting, and I'll touch on that in a minute. But that's a really positive way that we can use these materials and ID them and give them more of a meaning in the future. Conduct cover meter, ferro scanning. Obviously, we need to know what's in the slabs to begin with. Testing elements, testing regimes that we can do there. Propping the floors below. Obviously, we need to prop the floors below in order to stop any potential incidents around that. Install the lifting hooks, eyes, mark out a cut line, use the crane to lift them out, measure and cut the slabs intended at ground level, so not at the actual level themselves. We can do that at ground level or off-site if required. Unload it at a storage yard and assign an ID. And assigning an ID then allows the constructor, principal contractor, to then come in, pick what elements they want in certain areas, and then use them as best as they can. Now, I appreciate that little bit there was sort of into the future, but we have actually done this and we have tested this at Euston Tower, a project that Elaine mentioned a minute ago as well. So what you're seeing now is sort of a timeline of our works on site. So what we did, we started last year, this was some time ago, but what we did is we propped originally, set out, as you can see in the second picture with that yellow paint, we picked the slab there. We begun the cut, we ended the cut, so the cut took about 3 hours long to make sure it was all safe, but the actual cut time itself to get through the concrete was around about 10 minutes. That removal begun on a couple of days later safely. We jacked it up, got it out on trolleys, and then left site. Now, I'm well aware that probably a few people watching this are thinking that's quite a long time for a cut and removing of a concrete slab. Basically, the reason why we did this is to prove the process could be done, and we were being as slow as possible, really on purpose, to make sure that concrete element and the process was defined. On new projects, we're estimating that we could potentially get 30 or 40 slabs out per floor, and a lot larger than this. And then that reduction will be sped down. So we're looking at probably 3 or 4 days to get these concrete elements out as 40 slabs, not one. So that time frame is drastically reduced. I mentioned earlier on about material passporting, really handy and gives a lot of information to new construction elements. So what is in there, what is the type of concrete, we do that testing. What we've done is we've developed, using a digital platform, we've developed the material passporting and the naming conventions around that. So very simple in this respect. It's the floor number, it's the block that it was taken from, and then the slab number itself. What we're able to do, we're able to generate QR codes for each slab, input these details onto a digital platform. They can be accessed by anyone who's given access to it. So it's not information that's hid away. It can be used by architects, it can be used by future companies as well. We're well aware that not every slab might go back into the development, but gives the opportunity to others to reuse it as well. Can have photographic evidence within there, condition surveys, and also all of the information can be exported and downloaded into PDFs or CSVs, whatever people need to have that information. So we want to increase the likelihood that these items are going to be reused as much as possible, and information is obviously a huge part of that. Like I mentioned a minute ago, so this is sort of what you'd get if you looked at the QR code, and these slabs are all stickered up. So you have the general information down there, you have the dimensions, you have the testing, you can have the ferro scans or the testing documents all attached in there. So it's a one-stop shop for all of the information you need, which is integral for construction moving forward. So what is the benefit of Prex? Obviously, from a demolition contractor, it doesn't get the building down in the quickest way, but it enables these benefits here. So obviously the embodied carbon reduction in new builds, so implementation of Prex strategies during demolition significantly reduces the need for virgin concrete in slab elements, so that embodied carbon's reduced there. Optimizing mixed designs throughout the reuse strategies, so this links into PAS 2080 compliance and other areas like that, and also the concrete elements going back into slabs around the slabs in these new raft elements can be changed. Recycled aggregates can be increased, so lowering embodied carbon there. The most obvious one is obviously reduction in demolition waste. That waste is being reduced as far as possible, obviously with the concrete elements. And when you're talking about a tower, for example, something like Euston Tower, that is hundreds of tons of concrete that is being diverted from waste. I touched on this previously before, so minimizing the extraction of virgin aggregates. So reclaimed concrete can substitute primary aggregates. Obviously supports responsible sourcing and compliance with ISO 20400 and BS 8500 as well, in terms of that responsible resourcing of materials there. I mentioned this previously, so I won't talk about this too much, but enhanced material tracking and passporting. Obviously, there's a huge element of data that needs to be collected so these elements can go back into the structure. At the moment, traditional demolition techniques don't necessarily lend themselves to micro and really granular detail. And hopefully this is one way we can share this and be really confident that those Prex elements can go back into the building with enough data attached to them. Yeah, so that was fairly short and sweet, but that is information on Prex, and I look forward to any questions anyone's got towards the end of the Q&A.
That's great. Thanks, Tom. It's really useful to have some practical examples where things are actually happening rather than just the theory. And I think something that might come up in the questions, which I won't ask quite yet, but in terms of having a destination identified, I think that's something that would be quite interesting to explore, because I know reuse generally, if there is a need for a particular product, be it a concrete slab or be it a piece of timber or a kitchen unit in a commercial kitchen, if there's been a need identified, there's going to be much more justification and onus on that being taken out carefully, stored, moved on, and got to its destination. Whereas if you're actually reusing just because, or reclaiming because you think it's a good idea, that can cause issues and potentially for it not to happen, or something just end up into storage for a very long time. So
Great,
yeah, maybe you can explore that as part of the Q&A. That's brilliant. Thank you very much, Tom, for that. And we'll move on to Serkan now next, please.
Hello there. I hope you can hear my voice and can see my presentation.
Yep, that's great. Thank you.
Perfect. Thank you very much, and good afternoon all, and thank you very much for organizing this event. And it's a great opportunity to line up with these great presentations, because it's already the overview is presented and also one perspective is presented, and my presentation is aiming to fill one of the gaps that is being mentioned in the presentations, in the previous presentations. My name is Serkan Karatosun. I'm doing my PhD in the structural reuse project, and structural reuse projects aims to enable reuse of existing structural elements, which is, I guess, in the previous presentation as mentioned as the precast single elements, not to reuse existing structures, but reclaiming the existing structural elements from the buildings that's going to be demolished. And the structural reuse project aims to develop assessment guidelines for existing structures from concrete, steel, and timber, and led by the Elizabeth Ottosen. And my presentation is the outcome of my PhD work, which is the development and validation of a guideline for concrete elements. And I have great co-authors who helped me to develop and validate this process throughout years. Luckily, I don't need to mention too much about the background, because the importance is already mentioned and the potential is already mentioned. So I will straight go to the problem that we are trying to solve. For us, or for the industry, what we see, the documenting properties of structural elements for reuse is one of the main barriers to enable scalable reuse or make the reuse of structural elements mainstream. And the solution for us to use non-destructive testing methods and combining these non-destructive testing methods to document all the required properties for designing new structures using reclaimed elements. And the method that we choose to approach, because multiple methods can be applied, and the method that we choose to develop a standardized assessment procedure that can be applied by the industry directly, and to solve the first problem, or finishing with the first iteration, we choose to scope our guide into precast solid structural elements serviced in passive environmental exposure condition, because we believe this is the solvable maximum potential. But this is a live work, which means that it continuously needs to be continuously developed and further refined to make the solution better and better. Therefore, we are very keen to share our work, to get feedback from the professionals in the industry to make it better. And at the end, I will share a QR code to get your feedbacks. As every engineering problems, we have a constraint. Our constraint is this guideline should be able to use, or the practitioners or engineers should be able to perform practically, which means that we need to use well-standardized commercial methods and simple standardized applications. That's why actually, even though our work is published in Denmark, it is still valid or applicable in any part of the world, because all the methods or all the approaches that we are using is actually global solutions. Nothing is special for Denmark. I would like to share the rating group. I would like to credit my contributors. We have a national standardization body, Danish standards, Alexander from Danish standards, and Carolina from the Linea, which is already mentioned in the first presentation by Elaine about the case studies. And we have also Katya from DTU Sustain as a researcher. And on 12th of September, we had a final conference to celebrate our outputs, and the guideline is published also 12th of September in the final conference. And I would like to show also we have lots of partners from industry and from different part of the stakeholder in the reuse of structural elements. How we see the documentation should be in the journey of reusing structural elements. We believe that it should be done in the service life. The full documentation should be performed and finished in the service life, so the new structure can be designed in a good time to leave enough time to plan disassembly and the reassembly. And for that, we developed two-step reusability assessment. The first step is the viability assessment, which is a quick screening, and it helps to stakeholders to decision to invest further or not. And the second step is the quality assessment, which is the main part or the comprehensive testing part happened. And in this step, we document all the required properties for designing the new structures. And this is a summary of the reusable, the NDT-based approach that we are using. As every assessment of existing structure starts, we are starting with visual condition evaluation, and then we are starting to use our smart and nice tools that we love to use them. And with these tools, we are performing subsurface condition assessment to reveal the internal condition of the structural elements to see if they are okay, and then reinforcement assessment, and this is also mentioned as ferroscan assessment in the previous presentation, to locate the embedded structural objects, which is reinforcing bars. And the last and final part is the compressive strength assessment part. We have performed lots of case studies mainly in Denmark, but also in different parts of the world, but still a building associated with Denmark. And all these structures were aiming to reuse the existing structural elements. And some of them are already in part of, they finished the disassembly and waiting for the reassembly. The subsurface assessment is done by using a radar to see the internal condition like this, and followed by using an ultrasonic pulse echo device. Once again, it helps us to see what is inside of the concrete, so we can see if there is a defect or if there is any problem that can prevent the safe reuse. The next part is reinforcement assessment, and in this part we are once again using non-destructive testing methods, tools. In this step we are using the radar technologies to reveal where the reinforcement are embedded in the existing elements, and these hyperbolas shows us where the reinforcements are. This can be done without having any destructive performation, without giving any damage to the structural elements, but it needs to be calibrated once in a while by removing the cover of the concrete, which can be easily repairable because it doesn't also give any structural damage. The last part is the compressive strength assessment part, and it has 3 steps. First, using non-destructive testing to quickly screen all the properties that can be correlated to compressive strength, and then drilling a core to see the actual mechanical properties, and then building the correlation between the NDT and core strength, so we can use only NDT from that point, only NDT to assess the compressive strength assessment. And here's are some pictures from how we perform these things in the practice. The left part is the ultrasonic pulse velocity part that use an acoustic waves to assess the elastic properties of material, which is strongly correlated with the compressive strength or another mechanical properties. And the second part, the right part, is the rebound hammer, also known as Schmidt hammer, which helps us to understand the surface hardness of a material or surface hardness of an existing structural element, and then we can correlate that value with the compressive strength. To finalize the compressive strength assessment, we still need some cores, some samples, and we are actually trying to minimize this process but we still need these samples to test in the lab and get the actual properties that we can correlate with the NDT results. This is a brief show, like this is an exemplary show how the NDT and the compressive strength from core results are correlated. These types of graphs or these types of analysis helps us to develop an equation to convert the NDT value to compressive strength. And from this point forward, we don't need to take any more core samples, but we can use the NDT measurements, which is fully non-destructive and non-invasive and quick and quite reliable. Then we can use them in existing elements, new elements, and we can use this equation to convert that NDT value to compressive strength. This was the end of our procedure, and I have a question. As I said, we have lots of questions to ask to industry to learn more or to refine our work better. And one of the questions is, what if reliable and valid documentation exists? Because even though we are trying to develop a very practical approach, still it requires some time and money to invest. But what if reliable and valid documentation exists? And we believe if these the documents are available and can be checked by using very simple visual assessment and reinforcement check, maybe there is no need to conduct the full procedure, but focus on only the most important or most critical one. So for the conclusion, we developed and published a two-step reusability assessment to enable safe and scalable reuse. It includes viability and quality assessment. We are combining multiple NDT methods, and the document has already published, and we are looking for your feedbacks and comments to improve our work. And here's the QR code that I would really love if you can scan, and by scanning you can also reach to the document, but also there's a form with the questions that we will look forward to your answers. Thank you very much for your attention.
Thanks, Serkan. Yeah, a great presentation, and I think it's really important, I'm sure, also from an insurance perspective as well, to have that backup information to support that the process and prove that it is safe to reuse these concrete elements. I have put the link to the document in the webinar chat as well, but please support the work by giving your feedback as well. It's obviously super important for the team to get industry feedback on their work, and that feedback loop is a way that we can make sure that we continue to improve.
Thank
you very much. So just hand over to Laura, last but not least.
Hi, everyone. Just sharing my screen. Can you let me know when that's ready to go, Debbie?
Yep, sure. It's still loading at the moment, I think. Nothing coming through yet.
Okay.
Something looks as if it's happening. Yeah. That's good.
All good?
Yes.
Great. So, hi, everyone. My name is Laura Batty, and I'm a structural engineer at Heyne Tillett Steel, where I run the research and innovation team. So I get to kind of explore all these really interesting ideas outside of projects and try to implement them on projects. So reusing concrete, we've been looking at this at HTS for about 2-ish years, kind of off the back of the success of reusing steel. So today I'm going to talk to you about 2 case studies that we have in the office right now. So the first one is 1 Knightsbridge Green, which is in Westminster. It's on Brompton Road opposite Harrods, a really prominent location. The client is Beam, the architects are AHMM. And the original building was a kind of classic 1950s post-war building with a low floor to ceiling. It had like a double row of columns down the center corridor, kind of not great for the aspirations of the client. And as the design progressed, the amount of retention was gradually chipped away to eventually leave about 51% of the existing structure. So you can see here the proposals for the red is demolition, which is actually quite a lot, and then it would leave the sort of backside, the existing structure, and then the whole the new development would kind of take over the front side of the site. So Westminster wanted more reuse. We also really wanted to find a way to implement more reuse. So what we ended up proposing is to extract some slabs from the existing site and then reuse them as soft spot infills in the new floor plate. So on the top left, you can see a kind of proposal for cutting out the existing in situ concrete slabs into 4.5 meter long by 1.5 meter wide strips. And on the right-hand side is a slightly zoomed in view of that detail. And then using these as soft spot infills on the proposed floor. So that basically a soft spot would allow future flexibility for vertical circulation in the building, but in a way that is kind of easy to sort of punch through if the client wants to at a later date. So this is kind of like a perfect little test study for doing this kind of work, because the quantum is pretty small, admittedly, but we don't think it's ever been done before. And also the fact that it is a soft spot means it doesn't have to perform like a full diaphragm function as the new concrete slab would have to. So it's a technically slightly easier to achieve place to reuse concrete, and we're just essentially trying to reuse them as precast panels. So like I said, it's slightly small in ambition, but I don't think it's ever been done before. So we really are keen to get this done. And actually the planning has been approved, and this is a planning condition, so it will happen. So a little bit more detail on the technical side. So on the left-hand side, you can see a new concrete kind of edge support detail. And it's a bit of a tricky detail to get right, because we need to have enough support for the bearing of the new piece of concrete, the old piece of concrete, which is shown here in kind of light gray color. It needs to be robust, so we need to add a screed on top. And there is a little bit of tricky issues around the fire detailing. So in this project, we've shown a fireboard. Detailing for fires and reuse concrete is a little bit tricky because you don't have the continuity. So it's tricky to do without fireboarding. So on this particular project, we're proposing to board it. We're also proposing to reuse slabs in the foundation. So this is admittedly downcycling, because we're not using the slabs as they were designed to function in bending. They're just kind of filling in the neutral axis zones, but it's tangible and it's fairly easy to do, and it will make a big difference to the volume of material used in the foundations. So we were working alongside McGee on this project, like super critical to get input from contractors to make sure it's feasible, to understand the process, what hurdles that we as engineers may not have foreseen, etc. And they're super keen to get it to work as well. So it's really good to have that the shared motivation. In terms of the practicalities, often concrete panels may not be crushed on site because it's really noisy. And so there is a sort of significant experience of cutting into panels, maybe not perfectly reusable panels, but panels nonetheless, and then moving them off site and then break them up so that they can be no issue with noise, essentially. So we found that there was actually quite a lot of prior knowledge on lifting panels and keeping them intact, and make sure that the crane arrangement is stiff enough so it doesn't damage the panels. And so we found that it's pretty straightforward to understand how we're going to reclaim these and make sure that they stay in a state that they can be reused. And then so what we've found on this project is that McGee's have agreed to take responsibility for the panels in their temporary situations. So cutting, lifting, storing, bringing them back, and once they come back to site, essentially, they're going to guarantee that they're coming back to site as they left site. And this is, it's a responsibility that the contractor has agreed to take. You know, it's not necessarily, would not necessarily work on every project for every contractor, but in this case, we've been lucky that it's worked out. McGee's are being helpful. They want to do this. Tom, I'm sure you'd agree, that's a shared perspective. And so, you know, they're being helpful and proposing ideas. And this is really, really important, we found, is to have this kind of input early on, because each project will have its own bespoke little issues to get around. And then just to have a look at the impact. So if we were to, instead of the reused slabs, use CLT slabs or precast to do these soft spot infills, the amount of embodied carbon would obviously increase. Okay, so the next project I'll talk about is the Brunswick Centre, which is in Camden. This is a really iconic building. It was built in the 60s as a kind of utopian hub, loads of exposed concrete, a really iconic architecture, concrete on show as well. And it's a residential, loads of residential units. There is some retail, there's a cinema, there's a big car park. It's just a sort of cultural icon. So this project is working with Lazare as a client and the Whitbread Hub as a hotel operator, and Axiom Architects. So like I said, it's really iconic in the heart of Bloomsbury. This is a section from the original build that shows the scale of the substructure. So you might not have realized how big the site is overall, and how much car park there is actually underneath. Back in the 60s, like having a car park was a real selling point. This is one of the sort of marketing pieces, and a sort of aspirational, you know, living with cars. Cars were interwoven with London life, and we've really moved past that now in 2025. The basement car park is really underutilized. The residents can't really use many spaces, and neither can the retail units. It's fairly empty. It's just a bit, you know, underused. So they're looking at what they can do with the space. So in comes a subterranean hotel. So if you, the thought is, if you come to London, you don't really care about a view from the window. You're here to see the sights. So subterranean hotels are absolutely fine. We've actually done them before. So the idea would be to take the underground portion of the Brunswick Centre and turn it into a hotel. So as you can see from this slice through the building, the floor to floor heights, there's a 2-story basement currently. The floor to floor heights are 2.5 meters. And the hotel has need for lots of drainage, lots of acoustics. So actually it needs a floor to floor height of 4 meters. This section is a little bit deceptive. It's a really big area in plan. So when you look at it in plan, all the red in the left-hand side image would be demolished. To make way, basically to remove that slab, to make way for the space needed, the head height needed for the hotel. Another thing to talk about the Brunswick Centre is that it's really, the site is extremely constrained. There's lots of students in the area, lots of tourists, there's existing residential units. The client was very concerned that they were not going to be able to get planning because of these constraints. And also there was some pushback from the residential units about the upheaval that this construction would cause to them. They had to demonstrate really clearly and really think about what they were going to do about construction traffic in particular. So we did an early study about what it would take to demolish the B1 slab, so that intermediate basement slab. And just counting up the material that you'd have to shift, it's basically 73 days roughly of every, so essentially 3 months of skips to shift this rubble off site, which is really, really disruptive in a hugely constrained area with only one way in and out of the basement as well. So hopefully some of you may know where we're headed. Why don't we just move the floor down? So everyone on the team kind of came to the same conclusion as this project progressed. So we really took a good look at this several years ago, actually, with the help of a contractor, and explored what it would mean to shift the existing B1 floor down to the height that it was supposed to be. So this sequence shows the process, how you could do it. We initially thought we'd have to strengthen the columns, because when you shift the floor down, you make a column longer, and it's kind of a little bit less stable. So we thought we'd have to add a little bit of strengthening. The project's moved on now, and more detailed calculations have been done, and we've proven that we actually don't have to do anything to the columns. They're absolutely fine as they are. So the idea is to cut the slab out in kind of several bay chunks, and then drop the slab onto new dwarf walls that are cast kind of straight on top of the foundations. So technically it's pretty simple. Once planning, which has been approved, we got a contractor on board. So Erith has come on board now to kind of give their input into the proposal, and they've suggested to change it to a top hung. So instead of jacking from below, they're going to put some steel beams, temporary steel beams, at above the B1 height, hang the slab, and then drop it to the level that it needs to be at, which is a lot more sensible. And they've also worked up an option where they do kind of lots of different small parts, and another one where they do several really, really big panels in one go. And they see this as less risky. The option for 8 panels is less risky and quicker. So just to look at like whether this is kind of a crazy idea or not, it actually, so as I said, the idea came by because it was probably the most logical way to avoid disruption on site. But when you look at the numbers, the program savings of 22 weeks, cost reduction of 15%, suddenly all this really stacks up. This, by the way, is compared to a beam and block solution, the demo plus a new beam and block solution. And interestingly, the client was not too interested in carbon and even not too fussed on cost. And this still makes sense. So it's quite surprising and kind of encouraging for us, because we would have suggested this maybe to save carbon and to do something innovative and reuse concrete, but actually on loads of different metrics, it stacks up. So it's really encouraging, and this is going to take place very soon. So yeah, we're really excited about this one too. And that's all I have. So looking forward to answering any questions you may have. Thanks.
That's really, really, really interesting, Laura, and a kind of a counter case study to obviously what Deconstruct have done in terms of raising the floor, which is another case study that we've heard about recently, rather than demolishing a couple of floors and taking them out, and similar issues around noise pollution and traffic. And that's kind of what drove that innovation, and interesting that that's one of the drivers that brought you to that solution as well. We have quite a few questions, so I'm just going to pick up the ones that have got a couple of thumbs up. So one question, how does reuse of concrete sit within the current regulatory standards and landscape in the UK? Will reuse of concrete be addressed in the new Euro codes? What can the building safety regulator do to safely remove barriers to concrete reuse, especially in high-risk buildings that need to go through the planning gateways? Anybody want to pick up any of those? Elaine?
I knew you were going to come. There's a lot of questions there, and yeah, building safety regulations. I mean, yeah, there's a lot of questions in there just for new, let alone something that's reused. So it's just, there's quite a lot of unknowns. But I would say that in terms of so reuse in situ, so not moving it, I don't think there's really any barriers there. It's well understood. That's about assessment and being able to prove that it's appropriate and to continue using it by the standards of what's required. So I think for that isn't an issue, it isn't a blocker, and I wouldn't have thought that should be a problem for for building safety regulation either, but who knows? I mean, there's things being blocked that we don't really know why they're being blocked. So I think we might have to park that as a separate question. But I think it's fair to say that as soon as you start chopping things around and moving them around, that it becomes an extra layer of question, and there isn't yet standards in place to facilitate that. But I think maybe Laura can answer a little bit more in terms of her experience of doing it on those projects as to what barriers or workarounds they've been able to find. So interesting already seeing the difference of it being a soft spot requiring less requirements from a design point of view.
Yeah, I think that's not to do with HRBs or anything. It's just it doesn't exactly have to be like a really, really integral part of the floor. So we're a little bit lucky about that. But I would say that this is such a nascent way to build that I don't personally think we should be exploring kind of the issue of the building safety and HRBs yet, because we're starting to figure it out at a smaller state, at a smaller level. And like what you're trying to show in the gateways is kind of information and certainty. And we don't really have that yet for this kind of construction practice, because the supply chain isn't that developed. So we need to find smaller places to really kind of learn how to do it, and learn and share on each job. Each job will have its own lessons learned, and so I think we should like not run before we can walk, I think.
Thank you. Next question with 2 thumbs up. Kath, do you want to come off mute and ask it yourself?
Hello, can you hear me?
Yes.
Hi everyone,
Hello.
great presentations. Thank you. What did I ask? You caught me now. Which one?
Sorry,
Because I asked 2, didn't I?
what does good look like for reuse of precast concrete products?
Yeah, so I guess it's really hard to define, isn't it? Where can we get to, and what does it what does it look good for the sector in terms of the levels of reuse? That's both for products, and then I don't think this data exists, but I'm going to ask anyway. It would be really nice to know how many buildings are getting more refurbished where the structure's staying versus still getting demolished. So sort of two different questions there. Thanks, guys.
Maybe,
So,
sorry,
yeah,
Elaine.
go Tom. No, you go.
Maybe I can pick up on that sort of last point about the state of the industry. I think we're definitely seeing more and more, less and less straightforward demolition jobs, I think, and more cut and carve sort of situation jobs. And obviously with the cut and carve and the remodeling of buildings, that gives the opportunity for reuse, whether that be the prex that I talked about or the various different things that Laura's spoken about in her really good case studies there. They're brilliant. But yeah, so we're seeing more and more. I think there's a conversation, and I've just taken a look through the Q&As, and maybe this can answer a few of them there as well. But it all really depends on the commercial viability of it all as well. I think in the current climate, we need to be totally frank and honest that it will increase the program, and it will increase the cost of the project in its entirety. Which isn't to say it shouldn't be done. All endeavours should be made to do it, but we need to be perfectly honest around that. I think Debbie, you said something earlier on, and this links in with the commercial viability of it all. Is where are those materials going? If it is a project by project and a donor project, giving it to the new development, then that's got a lot of success because the developer's there. But obviously, if you start to bring new donors into it, there's a risk that the materials could just be sat at a location for a period of time, and then that increases the risk not only of people losing money, but the risk of those materials not being as good as when they first came off. I'm actually this morning still am there at a concrete manufacturer whose one concern was about this storage element, about moving things forward. So there needs to be that commercial viability moving forward. And like Laura said a minute ago, if there's a few small scale projects that show it can be done, then hopefully large scale projects will get the go ahead in the future.
I've got a few points to pick up on there. I think, yeah, Tom, you're absolutely right that it has to be practical. And that means it has to make sense in terms of program and cost. We're not going to win the argument just on sustainability. And so like, just to sort of give maybe a little bit more detail on the Knightsbridge Green, the costs came back as £2,000 per panel, which is slightly more than you'd pay for a precast solution having the same design, the same detailing, etc. But it wasn't actually a huge uplift. And in the context of a whole construction project, the client is willing to take that on, which is really positive. And the program has shown no length increase, but we also think this is because that they're trying to be helpful and they want to do this. So we had a different experience on another project where we proposed very similar soft spot infills and had them had the design priced by lots of different contractors, and they came back with such a variety of program extensions from kind of 3 months to no extension whatsoever, that it's true, it is a little bit of the Wild West right now. But it does have to make sense, and that's kind of why the moving floors is so sort of encouraging, because it does seem to also make sense in terms of time and money. But yeah, definitely would echo that it must be practical and efficient, not just not worth pursuing just because it seems interesting and is innovative. And I had some thoughts on the donor recipient model being different to products and reused steel in particular, because I think it's really, really important to have a use case for the element before it gets removed, because what you're going to do with it really affects how big you need to extract it, and kind of how it needs to be stored, etc. But I'm happy to pick that up if there is interest at a later date.
Did you have anything to add, Elaine?
Well, I need to say, hi, Kathleen, just said, yeah, it would be great if there was some more data on that. And I don't know, we certainly don't have it. I don't know whether there's something that the Federation of Demolition Contractors is able to collect, but I think there's a few bits of research going around, people starting to look at this. But actually, picking up on what Laura said, even if we know what buildings are there, we still actually don't yet know technically what the opportunities are for where it can be used. And getting into the detail of knowing what's capable requires us to know much more about our buildings. And sometimes we don't even know that, even when we know we're going to be doing work on it, because we can't get in because people are living in it or working in it. So I think, Laura, just I reiterate a lot and support a lot of what Laura is saying, because I think where we are at the moment is actually just trying to understand the practical, but also the technical capability and options of what is possible. And until we do that, we don't really know, we can't really predict the scale of what the opportunity is for its use either. We could make some very broad estimates, but they're not really worth, they're not worth much, are they? If I was going to guess now, I'd say what, 25%? But what's that based on? There's so many movable factors. Yeah.
Thank you. So another question, with Laura's case studies, you mentioned about where the concrete was going to, whereas I think Tom's example, were you kind of doing that to show the art of the possible and as a learning exercise, or was there actually an end user for those slabs?
Yeah, so the end user for the slabs would be going back into the development.
Building.
Yeah. So just to jump on what Laura said previously, and maybe this paints the picture a bit better, is that what we've done is we've looked at the possibility of reusing those slabs, which it is possible and it is feasible, and then we've also costed in the elements of storage as well. So there's that trade-off, I guess, between business as usual, demolition, crushing, recycled aggregates, and then storing the concrete. So we've looked at various different options, whether that be covered warehouses, whether that be pieces of land in and around London that people can go to, look at the slabs, decide whether they are using the information we've collected, whether they can go back onto the development or not, and also creates, I don't know, like a showroom, if you like, to have other people come out to use those slabs as well if they so wish. So yeah, we've looked at those options as well, and hopefully that creates a model of how it can be in the future.
Thanks. And I think that kind of dovetails a little bit into Tracy's question. I don't know if you want to come off mute, Tracy, and ask this about take back, because I guess that follows through in terms of when you're looking at your, doing your pre-redevelopment audit and you're looking to see what materials there are that could be reused in the building, and maybe then have kind of like a hierarchy to say, well, if we take the time to take that material down, they could be reused in situ, reused off-site, potentially take back process back to the manufacturer. So you've got kind of an option A, B, and C, just in case, because obviously things change as they go through the program. Tracy, do you want to ask your question?
Sure, thanks, Debbie. I think my question was rooted in maybe picking up on this donor to recipient model, specific client to specific client. I think there's a lot of value that focusing on the manufacturers could bring to this conversation, and I'm not sure if there's been work to, integrate that or test the feasibility of that, but concrete producers are often the ones with also with the equipment for transporting, and they know all of the best things about storage. So they're the experts that could really relieve a lot of the burden of logistics in terms of transporting material and storing material, and I'm just wondering if they could be explored as a potential, one of the potential pathways for addressing the logistics challenge when it comes to reuse. So yeah, whether or not that's been explored, and maybe it could be a way to pivot some of the conversations to engaging the suppliers and seeing if they could be an avenue for that.
Shall I pick that one up, Debbie? In terms of interesting question. I would say that in terms of storage and moving panels around, actually, a lot of the time it's not the industry who's moving it around. That's subcontracted to the manufacturer. So I think that moving things around exists as its own entity, and definitely the utilization of that is possible. But in terms of storage, there's not really much you need to know about in terms of storing concrete panels, to be honest. And so I think that it's something that we've discussed within our organization, and how can we do that, and what support could there be? Obviously, a lot of what we're talking about is in situ concrete being cut up. That isn't feasible at all. I mean, there's no space on a ready mix plant. There's no way they would be able to store that. So the logistics, and that they tend to be very local. So you're within sort of 12k of a site from a ready mix plant. There isn't the capability to do any of that storage there. So that's a complete disconnect. So we'd only be talking about precast. And in that respect, I would have said that there's more opportunities with regards to the design of those panels to facilitate them to be reused, rather than the logistics of the moving around and storage. That can be done by anybody. So I would say that that's where there is some potential. It could be about the way that the fixings are designed. It could be about are they embedded or not? How accessible are they? And that needs to be done in collaboration with designers as well, with regards to the aspiration for fire, how they are maintained. So people like Pico have been doing a lot of work in this space to facilitate that as part of that manufacturing capability. So yes, for facilitating disassembly, but I would say not for the extraction of existing. I think that's somewhere else.
Thank you. I think Olivia, if you want to come off mute, Olivia from Material Index has got a question for Tom.
Oh, hello.
Yeah,
Is
we
that
can hear you.
Okay, cool. Yeah, my question was, as we're completing a lot of pre-demolition audits, and I think our clients are seeing these innovative methods of reusing concrete kind of popping up and wanting to explore them on their schemes. But then also, I guess we're experiencing hesitancy towards conditioning from councils, which I think Laura also alluded to. So where we're involved in early stages, just wondering how best to assess feasibility of these types of, I guess, reuse opportunities, and what information we could be better collecting at pre-demolition audit stage to kind of facilitate those discussions.
Yeah, I jump on that, seeing as Debbie said it was for me. I think Laura could probably speak better surrounding the actual engineering information that is required to, and I guess that also depends on the purpose of the slabs and what they're going to be used for in the future. But I think from our point of view, as a contractor, we just need to be totally sure and have the accurate information of what these slabs are going to be reused for in the future. So whether that depends on whether they're going to be smaller cut, how they're getting out. Could it be a winch on the side of the building? Does it need to be craned out? Does it need to be dropped down through lift shafts and then trolleyed out? So they're sort of the things that we need to know in terms of program and costing that to the potential client. I mean, information-wise, I would assume that the normal testing elements would need to be done. What elements of reinforcement are in that concrete, and the actual testing of the concrete itself to see what that can stand up to engineering-wise. But I guess I'll pass over to Laura there because she knows far more about that than me.
Sure. I think from our perspective, we would need to know information about the existing asset. So if you've got like reinforcement details, and if they can be found, like archive searches, so that we can start understanding the design of the original structure, and then that can then inform what you can do with it. So, for example, we had one of the projects we explored, we found some information kind of late on that the reinforcement bars were plain, not twisted, and so that changes their capacity, which means we had to edit the new bearing detail to take into account that. So if we'd known that, it would have been nice because we wouldn't have to sort of redo the design. So any archive information about the original construction, and in absence, because we all know that doesn't always happen, on Knightsbridge Green, we were very lucky. We had full set of rebar drawings, which is incredibly useful. Then if you don't have that, it's all the things that Serkan was talking about, understanding what it is through non-destructive and then some destructive testing, so that again, it goes back to the difference between the donor recipient model. In situ concrete is not a catalogued element. It is bespoke every single time it's poured. So even if you have rebar details, you need to figure out a regime to confirm them on site, because if they've been drawn at a certain time and it wasn't a perfect as-built, there's never a perfect as-built. It has to be checked. So I think one thing that we can maybe get better at shouting about is the value of early stage, not too intrusive investigations, just to de-risk some of these things. Because as soon as you know the rebar pattern, as soon as you know the sort of capacity of the structure you're looking at, then you can start to really nail down the use cases. And like I said before, I think we need to have a use case to make it even possible to reclaim in situ concrete. It's not the same as another construction product. And then just the last thing is, like, existing buildings that have like regular bays where you could imagine a really efficient cutting pattern where you're not having to mess around with loads of corners and like reentrant and columns here and there. Like the Knightsbridge Green project is really lucky because it's got long, really uniform floor plates, and you can just like, just get loads and loads of product, because you're gonna lose some through damage. And as everyone kind of upskills, like some stuff is going to get lost. So you're probably going to need to cut more panels than you need in the design. And so having a floor plate that lends itself to being harvested is helpful. It's helpful. But yeah, I think just the opening up works to understand condition and details is really, really useful. And that's something that unfortunately can't be understood from a classic pre-demolition audit, because it does require bit of crashing through some existing concrete and opening up and looking at what there is in the absence of good archive information.
Thank you. Another question from Kath, I'll just quickly read. Are we seeking an uptake in demountable connections such as those by Pico, or is it a hard sell? As we know, the more we design it in now, the easier it will be in the future. Any offers on that one?
I would say, well, that obviously the more that's designed for disassembly, the more it's easier going to be in the future. But
Yeah.
I think I would still be wary about a hard sell necessarily that all structures got to be completely disassembled. I think that it's about working out what the most appropriate is, because we do know that often elements, if they're designed to be disassembled, there's usually an uplift in carbon because of the extraordinary connections that need to be done, or the lack of continuity from a structural point of view can make it less efficient. So we've got, I think we've got to, I personally think it's inappropriate for a blanket, every single thing needs to be designed to be disassembled and reused. I think that there is a case for some elements, so certainly things like infrastructure, where actually you want it to last for a long time, you want it to be in use and useful because of the ongoing, you don't want a railway bridge to be disassembled. You want it to be retained as a railway bridge for as long as possible because of this ongoing disruption. So I think it's about working out where those opportunities are. But that's not saying that the other elements, so the design for the disassembly of shorter lived area items, or the things that can be attached to the buildings or attached to the frame, there is scope for that, or maybe there's parts of a frame. So it's not a blank. I would say it's not a blanket yes to everything, but certainly I would think there's definitely scope for more.
Thanks. Just last couple of questions, and I've noticed Larry's popping in the chat as well about feedback form. If you wouldn't mind, the attendees just completing the feedback form, that would be super useful. I think quite interesting question here about if an architect wanted to find some concrete for reuse, how would they do that?
With great difficulty at the moment, I imagine. Yeah, so I mean, like we've alluded to already, not tons of this is happening at the moment, so it's fairly small scale. I mean, if an architect was really interested, I would suggest getting into contact with developers. I know previously we as a company have put on materials, so raw materials and sort of fixtures and fittings on things like material platforms. So you've got Material Index is obviously probably a good place to look, and there's a few others out there as well. So if they were really interested, you could see if they had any availability on there, and if not, I would suggest like going to developers, seeing if it's in their plans in the future, and then being at the front of that queue when it does become available.
Can I add into that, Tom? I think that's a really important point. It speaks to what Laura was saying, was the importance of being able to link up donor and supply. And I think that that's what's missing at the moment. And I think there's a real opportunity for people who have, where it's a large development, or where or people with estates, where they can manage their own development of projects, of being their own donor supply. But I think at the moment, there is a real opportunity, with platforms to be able and with the digital technology to be able to link up. Well, this is coming through, and you can, and that isn't that the whole principle of circular economy, isn't it? That we're meant to be not just saying what we want and then going and finding it. We should be designing things according to what's available. But how we do that in the reality of commercial development is a challenge. But so software and platforms that facilitate that would be really useful. At the moment, I think it's happening much more at a smaller product level. It's not yet really expanded into structure yet.
And I guess also with trying to encourage as much reuse in situ as possible, and in the potential scenario of the whole frame not being retained, in Laura's example, where you're able to cut some slabs and reuse what you can, potentially the remaining elements would just be, you know, crushed as you would normally and used for aggregate in that way. I think just to finish up, there are a couple of questions which I think have been covered, but if you want to give any last comments on that balance of environmental, commercial sensitivities, and why clients are doing this, that they might be embodied carbon driven, or not interested in the environment really. You know, it's great if we can do that, but do you know what? It's the fact if it decreases program and decreases cost. I think if you could perhaps just summarize on where you feel the market is with that in terms of asking for it, or whether you're having to suggest it, and then how those conversations are going in terms of that commercial environmental balance.
Yeah, I comment on that. So I think with everything that it differs from project to project, from client to client, if I'm totally honest. I think we as contractors are more than willing to have the conversation, because at the end of the day, in its crudest sense, the customer is always right. So we can go and we can look at these materials, and we can create a program. We can do them. We've shown there with the previous example at Euston Tower that it is possible. But what we need to do is make sure that as a collective, so that is client, architect, and contractor, there is a success model for this. So is it commercially viable? Where is that material going? It's all well and good spending the time and effort to try and get it out, but if it all is sat in a yard for potentially 1 or 2 years, and or potentially forever, and it's just going to end up as crushed anyway, we need to be honest. Is that a likely outcome? So I think it like Laura said earlier, the earlier the engagement and the more honest we are with, and the more accurate the data we have, hopefully that will lead to further success in the future.
Laura?
Yeah, I think that just from our perspective, is that having the constraint of the planning condition is really useful, because that has kind of forced the issue in a way, at least for the Knightsbridge Green project. I still really do think that it's the donor recipient model isn't the same, and we shouldn't be trying to force this into what we've developed, what we've kind of as an industry have come up with, you know, using like advanced matching tools and stuff. I don't think that is going to work yet for concrete, if we're being honest. It's running before we walk. And then the other thing is, yeah, I would say that it's funny, we keep trying to think of ways that, or reasons why jacking floors is a bad idea, and we just can't really think of them, and it just makes so much sense on loads of different perspectives. So I would encourage people to maybe explore, you know, especially working on constrained sites. It suddenly makes a lot of sense, and it's you know, on the reuse hierarchy, it's somewhere in between reuse in situ and reuse fully ex situ. It's like, it's not exactly reuse in situ, because you do have to do a lot of work to prove it, but you're not moving loads of material around and crushing it and downcycling it. So I'd really encourage people to explore. Like I've said, I've answered a few questions in the chat about whether that would work above ground. And so the Brunswick Centre is lucky because we're dropping onto the lowest level. And so the resupport is actually pretty simple. But we're developing a detail that could work above ground, so where you're moving a slab up. And it's tricky because of the monolithic nature of concrete, but we've got a detail that we think works. We just don't have a use case for it yet. But I would really encourage others to try and think about them, and, you know, we can work this out together. And then if we've got a detail that we're kind of confident as an industry, when the project comes along, we can kind of point to it and say, this is a valid detail that we should try out. So yeah, I think looking at the constraints and using them as opportunities.
Thank you very much. We're just at 2 o'clock there now, so I think we'll close proceedings off. Thank you very much to our 4 presenters for really interesting presentations there, and we had lots of questions, I think, which demonstrated the level of interest. I'm sure all 4 presenters will welcome contact afterwards if anybody's got any questions. We will be circulating the slides as well. And yeah, thank you very much for attending the webinar today, and look forward to catching up with you at another event soon. Thank you very much. Have a good afternoon.